Okay, welcome to page 43. Got rational and real numbers. So the real number system has a number of different categories. Let's start with the natural numbers. Those are kind of the most basic. They're your counting numbers. So we've got, I'll do set braces to show this is a set of numbers. And it just goes on forever. 1, 2, 3, 4. These are all the natural numbers. I will note that some mathematicians include 0 here and some do not. Ed Reddy does not. And so we're going to stick with the convention that 0 is not a natural number. Just know that if you hear someone else say it, it's not that they're wrong, it's just that they're using a different convention, a different rule. So for us, we're going to say the whole numbers are the natural numbers plus 0. 0, 1, 2, 3, 4, and so on. And then the integers include the negatives as well. So it goes off forever in both directions. -3, -2, -1, 0. And 0 does not have a negative because it's neither negative nor positive. Okay, rational numbers. Rational has the word ratio in it. That's no coincidence. It's a ratio of 2 integers, or any number that can be expressed as a, I want to say fraction, but that's, oh, ratio or fraction. Because those are basically the same, remember? And it includes repeating decimals, like 0.33333, and terminating decimals that end like 0.25. That's it. Irrational numbers are the ones that are not rational. It's any number that cannot be expressed as a ratio. So if repeating decimals and terminating decimals are rational, then it must be both non-repeating and non-terminating to fit in here. And we'll get some examples in a moment. And finally, the real numbers. All of these up here are real numbers, rationals and irrationals together. So we make the real numbers, which consist of any number along the real number line. So 5, 0.5, square root of 5, -5, all of those are real numbers. In this class, we'll only deal with real numbers. In 095, you'll get into some things called imaginary numbers and complex numbers. But for now, we're just sticking with the reals. Let's go ahead and get some symbols up here as well. The natural numbers. Notice I'm doing this is called a blackboard bold. So I put 2 lines, and then I write my N for natural. You can do the same thing with whole. And I do this just because it's a lot faster for me to write. This is a pretty common convention. Integers are not I, they're Z. That actually comes from the German Zahlen numbers. Rational numbers are Q for quotient. Again, all of these have this blackboard bold symbology. Irrational numbers are, you could do them a couple ways. I usually do IRR, just to be super clear. Probably the simplest. And then the real numbers are for real. So R is not rational, R is for real. So we have some quick ways of writing things. Let's also define, I've talked about non-terminating and non-repeating. So non-terminating decimals are decimals that continue forever. And non-repeating decimals are decimals that never form a repeating pattern. Okay, so we've got this diagram. Smartboard is not cooperating. There we go. Had to say something. Okay, so we have the real numbers. Or Blackboard Bold R. All of these numbers are real. We've got the irrationals and the rationals. Whoops, a little weird. Now, every real number is either rational or irrational. So these two categories together make up the real numbers. Notice that irrational numbers don't really have a lot of subcategories, don't really have any that I can think of. Rational numbers, however, do. We'll start with integers, which we remember is that Zalen. So we have integers, we have whole numbers, and we have natural numbers. This is not drawn as here are the integers, here are the whole numbers, here are the natural numbers, right? They're inside each other, they're stacked, because every natural number is also a whole number. And every whole number is also an integer. And every integer is also a rational. That is. Let's get some examples. So, natural number 3 is a natural number. It's also in the whole number bubble though. So 3 is also whole. It's also an integer. It's also in the rational rectangle. 3 is all of those things. Another example is 15. 15 is natural, whole, integer, rational. We could even write it a little funny if we wanted. We could say square root of 4. Well, the square root of 4 is just 2. So that's just written a little funny. We could do that. So for our next category, we ask ourselves, what are some whole numbers that are not natural numbers? And in fact, this is actually a very tricky question because I asked, what are some? I should have said, what is the only one? And what is it? Go back to your notes, pause the video if you need. 0. 0 is the only whole number that is not natural. It's the only thing that goes in this bubble. Integers that are not whole, we have a whole bunch of them, right? Anything that's negative cannot be a whole number or a natural number. Now, integers have to have no fraction or decimal part. They have to be just the opposite of natural numbers or whole numbers. So negative 31, negative 500, those are integers. 0 is also an integer. 0 is also in the integer bubble. 3 is also an integer. It's in that integer bubble. So integers do not have to be negative. It's just that that's the difference between whole numbers and integers. Okay, rational numbers. We can get all sorts of things in here. 4.2 repeating. That's rational. We can write it as a fraction. We don't need to know what it evaluates to know that it repeats, and therefore it can be written as a fraction. 6/7. That's a fraction. I wrote it as a ratio of one integer to another. So that's rational. Let's see, 5.02. That's a terminating decimal. That's rational. We could get a mixed number, 3 1/10. I can write that as a fraction. I'd have to do a little bit of math, but this is just turning it into an improper fraction, which we've done at the very beginning. So these are all, every red number in here is a rational number. It's not just these, it's all of these. These are all in the rational rectangle. Now the irrational rectangle has a few numbers. One of them is pi. Pi is one of the most common examples of an irrational number. And pi is a number that goes on and on and on. It never goes into a repeating pattern. Notice we do repeat digits. I've got a 1 and then I've got another 1, but it's not followed by a 4, it's followed by a 5, then a 9, and it keeps going. And it never falls into a pattern where it repeats. Okay, so there's pi. Let's do that. E is similar, 2.71828. Actually, the next part is 1828 again. You think it repeats, but it doesn't. The next one after that is a 4. Okay, square roots. Square roots that are not nice are irrational. So what I mean by not nice, that's very loose terminology. Square root of 2, that's about 1.414. It doesn't repeat though. And so on. Square root of 17, that's not a nice number. In fact, the square root of something that is not a perfect square, the square root of a whole number that is not a perfect square is going to give you kind of a mess. And that's what the irrational numbers are. We could also have, well, that's pretty much covered. Okay, let's take a look at page 44. So we have some numbers and we're trying to complete the chart. We're trying to say this is natural, this is real, this is whatever it is. So let's look at negative 0.84 with a bar over it. Is it natural? Well, no, that's definitely not a counting number. Whole? Nope. Integer? No, it has a decimal part. It's not the opposite of a whole number. It's not a whole number. So it's not an integer. It's none of those. Is it rational? Take a moment and think about that. Pause it if you need to. And this number repeats. So yes, it is rational. And every rational number is real. Because it's rational, it cannot be irrational. Every number on here should be in one of these two categories, either rational or irrational. Every number on here will be a real number. So those are a few hints. Let's do another one. Let's do square root of 9. Well, square root of 9 is really 3. 3 is a natural number. It's a whole number. It's an integer. It's a rational. If natural, I can just check the next few boxes automatically because they're in those larger and larger bubbles. And is it a real number? Yes, it is. So I think of the bubbles kind of like those nesting dolls where you have the little tiny one and then the bigger one and bigger one and bigger one. If you put something inside a small one and then you put a bigger one around it, that something is still in the bigger one as well. Okay, and we have some true-false statements. Let's look at number 1. Some whole numbers are also irrational numbers. So think for yourself, is that true? Some whole numbers are also irrational? Well, no, if it's a whole number, it cannot be irrational. It cannot be irrational. So we're going to mark that off. We're going to call that false, and it says correct the false statements by changing the underlined word. So what word would go there? Would it be all whole numbers are also irrational? No. No whole numbers. No whole numbers are also irrational numbers. So you'll do something similar. Some of these are true and you can leave them alone. Just mark with a T, and some of them are false and you'll need to change that underlined word. Okay.